This section, we're going to combine a few different of the book sections to go over solving quadratic equations. And as you can see, there are at least 5 different methods that we can use to approach solving quadratic equations, which just means the equation has an x squared term and no higher exponents than 2. So we can graph, we can use square roots, we can factor, which we've done before. We can do something called completing the square, which we're not going to learn how to do in Algebra 1. You probably will in Algebra 2. And then use the quadratic formula, which we will learn how to do. So the first approach is to graph. So this goes back to Chapter 8, where you learned how to graph a quadratic. So some of this might be review, but the first thing that I'm going to do is set this equation equal to 0. So I'm going to subtract 3 from both sides. None of these are like terms, so it's x squared plus 2x minus 3 equals 0. Now, whether you remember or not, you find the x-coordinate of the vertex by taking negative b over 2a. And the coefficients in front of the x squared term is a, and in front of the x term is b, and the constant is c. So I'm going to be taking a negative 2 over 2 times a, which is 1, which is negative 2 over 2, which is negative 1. So the x-coordinate of the vertex is negative 1. The y-coordinate is found when you plug in negative 1. So negative 1 squared plus 2 times negative 1 minus 3. So negative 1 squared is 1. 2 times negative 1 is a minus 2. Minus 3, so 1 minus 2 is negative 1, minus 3 is negative 4. So the vertex of this parabola is negative 1, negative 4. So I'll go to negative 1, negative 4, and I'll plot the vertex. And then my standard movements are to go over 1, up 1, over 1, up 3, over 1, up 5. So from the vertex, I'm going to go right 1, up 1. From that point, I'm going to go right 1, up 3. And then from that point, I'm going to go over 1, up 1, 2, 3, 4, 5. And then from the vertex, I'm going to go left 1, up 1, left 1, up 3, left 1, up 5. And you're going, Miss Barrett, we already did this. Why am I doing this? Because the answer is not this picture. The answer or answers are whatever x values make this equation true. So what numbers could you plug into that equation and get the correct answer? And so what I'm looking for is on the x-axis. So the answers, the solutions, the zeros, whatever word they use, find the zeros, find the solutions, solve the equation by graphing, is to find the x-intercepts. So since the x-intercepts are positive 1 and negative 3, the two answers are positive 1 and negative 3. So you have to know how to solve by graphing, but then once you solve, or once you graph, your answers are the x-intercepts. So number 2 is x squared minus 8x plus 16 equals 0. So to find the vertex, I'm going to take a negative b, which is a negative 8, which is 8, divided by 2 times a, which is 1. So 8 divided by 2, which is 4. And then I'm going to plug in a 4. So 4 squared minus 8 times 4 plus 16 equals 0. So 16, or not equals 0. We're just solving for the y-coordinate of the vertex right now. So 16 minus 32 plus 16. Whatever order you choose to combine these, I do end up getting 0. So that means the vertex is 4, 0. So I'm going to go to 1, 2, 3, 4, 0. Plot the point. The standard movements are to go over 1, up 1, over 1, up 3, over 1 up 5. So from that vertex, I'll go over 1 up 1, over 1 up 3, and I think that's as far as I'm going to go. Because the whole point of solving by graphing is to find where this parabola crosses the x-axis. And there's only one place where this parabola crosses the x-axis. So the only number that you're going to plug into this equation and get 0 is a positive 4. So there's only one solution, and it is positive 4. Number 3 says negative x squared equals 2x plus 4. Now, if I were graphing this, just so that I can keep my standard movements, I think I'm going to add the x squared over to the other side. So I've got 0 equals x squared plus 2x plus 4. Okay, so let's find A, B, and C. So A is 1, B is 2, C is 4. If I had moved the 2x and the 4, I would be dealing with negative numbers, so I'd actually be looking at like the flipped parabola, but I'm still going to get the same answer as far as where it crosses the x-axis. So I'm going to do negative b over 2a, so negative 2 over 2 times 1 is negative 2 over 2, which is negative 1. And then I'm going to plug in a negative 1, so negative 1 squared plus 2 times negative 1 plus 4. So negative 1 squared is 1. Minus 2 plus 4 is 5 minus 2, so 3. So the vertex of this parabola is negative 1, 3. And then my standard movements, I'm going to go over 1 up 1, over 1 up 3, over 1 up 1, over 1 up 3. So hopefully you notice something about this green parabola. I can continue to go over 1 up 5 or over 1 up 7. I could keep going forever. When is this parabola going to cross the x-axis? It's not. It's never going to. So when is this equation going to be true? Never. There is no solution. So something that it's important to recognize is that you're going to have one of three things happen. You're either going to have two answers because it crosses the x-axis twice. You'll have maybe one answer because it just touches the x-axis.